Mastering predictive analytics. We'll only thrive when predictive models fuel our business decisions. When will our organization be able to successfully integrate and deploy our predictive models into production environments, such as through application programming interfaces, APIs, or batch processing methods, in order to leverage their predictive capabilities and drive informed business decisions? To successfully integrate and deploy predictive models into production environments, it is essential to follow a structured approach that encompasses several key steps. First and foremost, it is crucial to develop a robust predictive model that has been thoroughly tested and validated. This involves selecting the most relevant and accurate algorithm, feature engineering, tuning hyperparameters, and evaluating the model's performance using relevant metrics. Additionally, it is essential to ensure that the model is interpretable, transparent, and explainable, as this will facilitate trust and adoption by stakeholders. Once a reliable predictive model has been developed, the next step is to design and implement a scalable and efficient deployment strategy. This involves selecting the most suitable deployment approach, such as APIs or batch processing, based on factors such as the type of prediction, data velocity, and latency requirements. For instance, APIs are suitable for real-time predictions, whereas batch processing is more appropriate for batch-oriented predictions. To deploy predictive models through APIs, it is necessary to create a RESTful API that exposes the model's predictive capabilities to other systems and applications. This involves designing a suitable API architecture, selecting a programming language and framework, and implementing API endpoints that enable data ingestion, model inference, and result serialization. Moreover, it is essential to ensure that the API is secure, scalable, and fault-tolerant, with adequate logging, monitoring, and error handling mechanisms. On the other hand, batch processing involves designing and implementing a data pipeline that integrates with the predictive model. This requires selecting a suitable scheduling framework, such as Apache Airflow or Celery, and implementing a workflow that orchestrates data ingestion, model inference, and result serialization. Moreover, it is necessary to ensure that the pipeline is scalable, fault-tolerant, and monitorable, with adequate logging and error handling mechanisms. Regardless of the deployment approach, it is essential to ensure that the predictive model is containerized using a framework such as Docker, and deployed on a cloud platform or on-premises infrastructure using a suitable orchestration framework such as Kubernetes. This enables scalability, high availability, and rolling updates, while minimizing downtime and ensuring seamless integration with other systems and applications. Another critical aspect of deploying predictive models is data management. This involves designing and implementing a data pipeline that integrates with the predictive model, ensuring that data is ingested, processed, and transformed in a scalable and efficient manner. This requires selecting a suitable data processing framework, such as Apache Spark or Apache Flink, and implementing a workflow that orchestrates data ingest, data transformation, and data serialization. To ensure seamless integration with other systems and applications, it is essential to implement a suitable data serialization format, such as JSON or Avro, and design a data schema that is scalable, flexible, and adaptable to changing business requirements. Moreover, it is necessary to ensure that data quality, integrity, and security are maintained throughout the data pipeline, using techniques such as data validation, data cleansing, and data encryption. Finally, it is essential to establish a culture of continuous improvement and refinement, where predictive models are continuously monitored, evaluated, and refined to ensure that they remain accurate, reliable, and effective. This involves implementing a feedback loop that integrates with the predictive model, enabling continuous learning and adaptation to changing business requirements and environmental factors. This requires selecting a suitable monitoring framework, such as Prometheus or Grafana, and implementing a workflow that orchestrates model evaluation, hyperparameter tuning, and model refinement. By following this structured approach, organizations can successfully integrate and deploy their predictive models into production environments, leveraging their predictive capabilities to drive informed business decisions and gain a competitive edge in the marketplace.